Humans have always had an interest in space. Over time, we've landed with a particular interest in Mars, and it's easy to see why. The relative similarities Mars shares with Earth gives it a particular intrigue as we probe with the newest generations of robotic explorers to discover its secrets. Mars stands at the forefront of our headlines in our quest for discovery and understanding as the new generations of robotic explorers probe through the red planet, aiming to discover its secrets. But one day, they won't be alone. Whether we're sending a small crew or shuttling ships full of colonists with a one-way ticket to the new land, someday, someone will become the first person to die on Mars. Since it will likely prove costly to ship the body back, chances are the bodies will have to stay there. But what happens next? Humans evolved and are suited best for Earth's environment. On Earth, humans eventually decompose as the environment is built to finally recycle its biomass. Certain organisms were made for this. They've evolved to exploit the biomass of dead organisms. When a person dies, several things happen. As early as 15 to 20 minutes after death, a process known as pallor mortis sets in. This causes an after-death paleness that occurs in those with light skin. Next, algor mortis causes a reduction in body temperature, only settling when it matches the ambient temperature. Rigor mortis causes the body to become stiff within 2 to 6 hours of death. By hour 6, the blood begins to settle in the lower portion of the body due to gravity in a process called livor mortis. Then, cells begin to break down as the body's own enzymes destroy them in a process called autolysis. Putrefaction is caused by the decomposition of organic matter by bacteria or fungi. This causes significant discoloration and bloating, often seen in corpses. Soon after, it is up to the scavengers, birds, insects, and other animals, as well as fungi and bacteria, to do away with the rest of the body. On Earth, the main factor contributing to decomposition is temperature. It is an important factor for the things that metabolize, that eat human tissues. Insects being the primary scavengers of human soft tissues, insect activity is temperature dependent. Sublimation occurs in freezing environments. The frozen water escapes to gas without going through the liquid form. The same way wet clothes can still dry hanging outside in the winter. So, on Earth with freezing environments, water sublimates and the cold stops processes such as autolysis, and sublimation desiccates remains and creates mummies. In the past, Mars may have looked a lot like Earth. Today, however, it is a cold and dry planet with an exceedingly thin environment composed of nearly 95% carbon dioxide and less than 1% oxygen. The average temperature is around negative 81 degrees Fahrenheit, or negative 63 degrees Celsius, and this can vary greatly on location and season. This, added on to the fact that there is no known liquid water on the surface of Mars, will cause complications in the decomposition process. A body that is left on the surface or buried beneath the loose soil of Mars would mummify rather than decompose. The first few stages, algor mortis, livor mortis, and rigor mortis, would still take place, but there might be almost no other overt signs of decomposition. Autolysis and putrefaction would continue until the body froze, with one significant caveat. Most of the bacteria in our body are aerobic, meaning they need oxygen to function. On Mars, only the anaerobic bacteria that don't require oxygen could proliferate until freezing, which means putrefaction would be severely limited. Once frozen, the body will dry out. Sublimation will cause any moisture to turn to gas and would leave behind an incredibly well-preserved and natural mummy. The desiccated tissues would likely be very stable for an indefinite period, a lot like the peat bog bodies in medieval Europe. These bogs were so oxygen deficient, they limited the body's own breakdown processes, thus preventing anything from coming in. The thought of mummies might seem cool, especially perfectly preserved ones. But if human settlements on Mars were to truly take off, cemeteries may require a bit of zoning planning and forethought, as the bodies in them would not decompose, preventing the reuse of plots. On Earth, the biomass form is absorbed back into its environment. On Mars, if this doesn't happen, a sizable amount of space would be slated off for these perfectly preserved mummies. While cremation is a popular and efficient body disposal option on Earth, it will probably not be the best method on Mars. Cremation requires keeping a chamber in excess of 1000 degrees Fahrenheit, or 538 degrees Celsius, for several hours, which in turn requires immense energy input. In an environment where such fuel could be limited, that could be a costly solution. But both burial and cremation have a significant downside: the loss of potentially precious biomass. Getting rid of the body, however, can be seen as a loss of resources. It might be best to bury a body in a temperature and moisture-controlled, Earth-like decomposition greenhouse with organisms such as insects and fungi to eventually turn that body into usable fertilizer or soil. But those organisms will need something to eat when no bodies are available, which may cause issues going forward. Evolution is ongoing. Things can change, create, and adapt very quickly. We could carry something from Earth, which can adapt, evolve, and grow into something different. We won't know until it happens, but there is a real possibility that this new microorganism could take advantage of the potential food source and thrive on an environment like Mars. The only remains on Mars, for the time being, are defunct robots that dot the landscape and gather layers of rust-red dust. When humans arrive, we'll have plenty to plan for or learn to overcome with time. Bodies might not decompose the same, but we won't know for sure until we live through colonization's trial and error process. This is a Ranger exclusive video. If you haven't already, press the like button and subscribe for more content.